We're going over now, final exam, part 1, super important questions. And this one is asking you to solve for x. So it's not your standard form equation where you solve for x and all you have to do in a linear equation is subtract from both sides or divide or multiply. Those ones I think you have a handle on. This one is not a linear equation. Does anybody know what I mean? What is the degree of the x term here?
X squared.
X squared, that's right. So that makes it a curve. It's not linear when you look at it in a graph. But for the purposes of this question, you're solving for x. What's our first step? You have to get x on its own.
Yeah, so you subtract y.
Subtract y? Not exactly, but what would you do? Divide by y.
Sorry.
Go ahead, divide y.
Sorry.
There you go. Pretty much. So you divide by y. Now we're left with g over y equals x squared. G over y equals x squared. Now what do we do? Because now we have an x squared on this side. This is what we've been doing the last week or so. When we deal with x squared terms and we want to get it down to x, how do we do it? Do we know, David? Square root, and I'll do it with, go ahead with red. We take the square root on both sides. There we go. X equals the square root of g over y. Square root of g. Good for you. Actually, we need to put plus or minus the square root of g over y, technically. Plus or minus, plus or minus. Okay? So there you go. That's an example of the kind of question you're going to get. Very similar to what you'll get on the final. Please study that. Write using standard notation. What we use the word standard notation and scientific notation interchangeably. This is 4.78 times 10 to the negative 3. This is already in a form that's very condensed, but they want you to write it as a full decimal. So you need to know what that negative exponent means and where it shifts the things. Jamie? 3 points to the left, that's right. Negative exponent takes it 3 points to the left, so we have point what?
00478.
There you go, 00478. That's exactly right. And because it went 1, 2, 3, you had to put 2 zeros in there to make that work. Now, another type of question was very similar. On this one, they're asking you to write it using scientific notation, and that means something like that looks like this. Can you please describe scientific notation, Ben? Go ahead, describe scientific notation.
It has to be a number 1 through
10. Yeah, 1 through 9. This number here has to be anywhere from 1 through 9. And then what about the way it looks with the decimal point?
Does it have to be after the first number?
It has to have one. Yes, the decimal point has to be after the one number, the 1 through 9. So it goes number, decimal point, and then any amount of numbers after that, but it has to be of this form. And then times 10 to the exponent. It could be a negative exponent, it could be a positive exponent, but that's the form of scientific notation. So we want to write it using scientific notation. How do we take that and make it look like scientific notation format? Yes, Ben?
So you see 1 to the left 5 times.
Yeah.
You put 5.67 times 10 to the negative 5.
Yes, so 5.67 times 10 to the negative 5, because you had to count, to put it in this form, to make it look like this, with a number and then a decimal point and then numbers after it, you had to count over, Lucas. How many points did you have to count over to get there? Right here, you got to put these little things, 2, 3, 4, 5, right there. How many points is that? 5, exactly. 1, 2, 3, 4, 5 points over to get there, and that's what scientific notation is all about. So on this one, you're also writing this one as scientific notation. It's 3 times 10 to the 4th over 6 times 10 to the 8th.
You divide.
You got to divide, right? So what do you do to these are the same base, right?
So you subtract.
So you subtract exponents, exactly. What's 3 divided by 6?
2.
That's right, this goes 1 into 2, so it's equal to 1, yeah, over 2. All right, so it's 1 over 2. Now this is going to, the 4 minus is basically going to be like this, times 10 to the 4 minus 8, right? Because you subtract exponents. So what is 1/2 times 10 to the 4 minus 8? 1/2 times 10 to the negative 4. And they want it in scientific notations. Let's put this as a decimal because, all right, because that's what we're dealing with here. 0.5 times 10 to the negative 4. Is this scientific notation? Is that the form we want to leave it in?
No.
No, we have to do something to that. What do we have to do?
We have to move it up.
We have to move it over.
Move it 1 to the right.
Okay. Scientific notation, that's right, we have to move it that way 1. So now this is tricky, right? We're going to
5
put
times 10 to the negative 3.
5.0 times 10 to the negative 3. Does that make sense? Or should it be negative 5?
No, that's negative 5.
Negative 5, that's right, because negative 3 is going to make it bigger. This is going to make it smaller. So what we've done, this is tricky, very tricky. What we've done here is we've taken 0.5, and we've made this bigger. 0.5 has become 5. So to compensate, we have to make this smaller. What's smaller than negative 4, Jessica?
That's going to fall in something.
Negative 5, right? Negative 4 is smaller than negative 5, so we have to compensate that way, okay? Okay, so these couple different questions, they're a little tricky, that's why they're up there. They're not, the material itself is not necessarily difficult, but they are tricky questions. 7xy squared minus 4x squared y minus, now you have these two parentheses, the big square and the small one, because you have an embedded expression, okay? xy squared plus 4x squared y, and then minus xy. So when you have this kind of questions, I don't know if you remember, we always work from the inside out. And which parentheses is the inside? Where do we start?
Very, very inside.
Would be, remember I used to go over with my left hand, I used to go across like this?
Yeah.
Where do I stop?
There.
Right here. So, but can we add this and this together? Can we add that together?
That would be 4.
Well, what are the conditions to adding things together? What do you have to have? What do you have to have? Yeah, you said it. You got it, David. Like terms. So, David, xy squared and x squared y, are those like terms?
No.
Kind of. But kind of doesn't count, does it? So, can you add these? No, you can't add them because they're not like terms unless they're exactly the same. The number can be different in front, but the actual term itself has to be the same to add them or subtract them. xy squared is not the same as x squared y. So, what can we do? We can't add that to that. We can't combine this to this either. But what can we do? Distribute the negative. So we work our way out. We could do that onto that, that onto that, and that onto that. So we rewrite it. It's 7xy squared, okay? Minus 4x squared y minus xy squared, and keep going, Katie, minus 4x squared y. Write it down, please. Minus 4x squared y plus xy.
No, but
Plus xy. All right? Plus xy, because the negative goes onto the negative and we end up with plus xy. Now we've got like terms, right? Now we've opened the thing up, so now we can find the like terms. Which ones are which? Put a check mark over the xy squareds. Can you see more than one over here? Jonathan?
yeah.
We've got 7xy squared there. And where else do we have 7? Do we have any more? That's xy squared? Good. So let's put a check there. So what else do we have? Any more xy squareds? No. Let's put them together. 7xy squared minus 1xy squared. What else do we have?
4x
X squared y.
Why don't you just do the math right there?
minus 4x squared y minus 4x squared y.
Good. So let's put those together. Go ahead, Katie. Minus 4x squared y. Go ahead and put those together. Turn around.
It's only when you're
And then we've got our plus xy. We can't do anything with that, so just put plus xy. Now we can go ahead and add those two or subtract them because we've grouped them all together in the right places. So 7xy squared minus 1xy squared is equal to what? 6xy squared.
Minus 8x squared y plus xy.
Yeah, plus xy. Good.
and you can't do anything else.
Really?
That's it. That's the final answer. Any questions with that? You can't do anything else with that. The real key to this question is recognizing which terms are common. What are the common like terms? All right, that was the trick to this question. Again, straightforward concept. We've all done it before, but on the final, you're going to get these tricky looking things. You really need to go over this and try this on your own on YouTube. It's probably harder than that package I gave you. And it's probably harder than what you get in the cumulative review. And that's why I'm putting it on YouTube, and that's why I'm spending time in class going over it. There'll be questions that will be on YouTube that won't be gone over in this class because I'm going to go over different ones in the other class. So altogether, you're going to have a big comprehensive bunch of questions that you need to review for the final. Very, very important.